Hello and welcome to this RapidMiner tutorial. In the video on model selection, we left off with a cliffhanger about optimization. Now we don't want to leave you hanging any longer, so here we'll show you how parameter optimization can be easily achieved in RapidMiner. So let's get started. We will repurpose the process created in the model selection tutorial, which you can see displayed here. In case this is the first video from our series which you're watching, then make sure to download the process and the data used here from our website. In our data loading via a process video, you can see how to import the processes and the data. Now back to parameter optimization and our process here. In the cross-validation, we have a decision tree model for which we want to find the optimal parameter settings. We will optimize our accuracy by identifying the best combination of the criterion to be used for splitting of the attributes and the minimal gain. The criterion selection defines the criterion by which attributes will be selected for splitting, and the minimal gain governs the threshold which we're requesting in order to allow the next split. The optimization is done via one of RapidMiner's optimize parameters operators. We will use the grid version. Before we do that, let's first save the process in our repository as 07 parameter optimization. And while we're doing housekeeping, let's disable the compare rocks and the multiply operators, since we won't need them here. Now let's just cut the cross-validation out, connect the optimization instead, then paste the cross-validation as a whole into the optimize parameters operator. After connecting the in and output of the cross-validation operator, we're now ready to define the parameters which we want to optimize. All right, so let's select the Edit Parameter Settings wizard. As mentioned, we want to optimize the model's parameters. So we select the decision tree first. Second step is to select our first parameter, the criterion, which then populates the rest of the dialog. We can leave all the defaults as we just want to loop through all the criteria available. We see information displayed that we're now creating 4 combinations, which is intuitive given the number of criteria. The second parameter which we want to select for optimization is the minimal gain. This parameter controls how soon splits are being made. So the lower the threshold value is, the larger the tree grows. Now that the dialog has populated further, we can define how we vary the criterion. To find out if 0.1, which is the default, is a good choice, we'll just test with a higher and lower value through 100 steps. We've configured 404 parameter combinations, and given that we're having a 10-fold cross-validation in each loop, it means we're truly producing over 4,000 decision trees. As you can imagine, this can become pretty computation and runtime intensive, so you want to be careful about selecting the number of parameter and the granularity of your optimization. Now we can close this dialog, but before we start the process, which will deliver us the optimized performance and the parameters combination used for that, we will add a log operator so we can take a bit of a closer look afterwards about what happened during the optimization. We could specify a file name to create a file dump of the log, but we just want to have a quick look at the log, so let's move on to edit the list of content for logging. We certainly want to see the parameters we're optimizing for, so let's add gain and criterion first. Be careful to select the right instance of the decision tree here. The one with the number 2 in brackets is the one in our currently disabled compare rocks operator. Further, let's add an iteration counter, and of course, we want to know what the performance of each loop was, so let's add that as well. For both of the latter 2 list items, be very careful to retrieve the information of the cross-validation and not from the model or even the performance operator, because if you do that, you're logging values inside the cross-validation, which are generated using the subsets in our 10-fold cross-validation. Okay, so we apply a count to the cross-validation, and then we log the performance value of the cross-validation. Let me repeat this. Don't log the performance of the performance operator, as that will only output the value of the last fold of each iteration going through the cross-validation. But you're usually only interested in the average performance over all folds of the cross-validation. Okay, now let's hit F11 to run this. Nice, our performance is roughly 85% with our optimized parameters as shown here. As you can see, the minimal gain is close to the default of the decision tree, which is set to 0.1. But the criterion accuracy seems to yield a higher accuracy. To find out more, let's take a look at the log. We can see that the iterations were performed for each combination of gain and criterion, and the log shows the performance for each. If we briefly create a chart displaying the parameters we varied and the performance for the different combinations, then we see that it is not useful to define a minimal gain parameter higher than 0.3. And if we zoom into the area with the highest performance, then we see that the accuracy was clearly the best split criterion to use. All right, this concludes our tutorial on parameter optimization. Make sure to check out also the model selection module and the one on automation, which shows you an optimization using more than one model. Thank you for watching.